I am Lakshman Kishan Lonkar, QFE scholar, EC department in NIT Trichy, pursuing PhD under Dr. Malargudi, Madam Professor, EC department. The title of the paper is Adaptive Residual Guided Data Fusion and Error Mitigation Framework for Real-Time Multi-Sensor IoT. The paper ID is 10899. These are the topics I am going to cover. Nowadays there will be huge amount of data which is generated from the IoT, and not only in the only one application like healthcare, but if you consider any different applications also, like environmental monitoring and smart cities, industrial automation. In that also IoT generate the huge amount of data, and that data is not generated from the only one source, but that data is generated from the heterogeneous sources, and different sources. And that the data also become a large that data also generated at a very large scale. And this data is can be generated from the distributed edge devices also. So multi-sensor environmentals often face some noise issue, missing values, and communication error. So traditional machine learning approaches, they are having some difficulties while handling this much of huge amount of data, and they are also failed to capture the complex pattern. So if you want for reliable decision making system, then we should have to go for accurate data fusion. So in the motivation, like if you consider only CNN model, and if you consider only LSTM model, or if you consider only ZNN or VNN, so these all the models are not handling this much of use of data, and they are not reliable for the anomaly detection also. So if you consider recent model, like transformer model also, that is having the very high computational cost. These are the problem statements. I have to generate a very noisy data, and that noisy data become affected that noisy data can affect for the decision making systems. Also they are getting some weekly anomaly detection, and they are poor real time adaptability. So we need accurate and reliable hybrid. We have performing this we are proposing this new architecture, that CNN LSTM. If you here we can see there are two layers. In one CNN layer, where input layer in we are using CNN, and in second layer you are using LSTM measure. Not only CNN and LSTM architecture, but here we are also incorporating our attention layer also. And after getting the fusion of these two layer, we are getting the output, getting one in within one pipeline we are getting data fusion model, and second pipeline we are using error mitigation model. So in the data fusion model, we are adding CNN and LSTM, and error mitigation we are adding that real time data correction also we are doing here. Also you are finding out the error correction and error detection model we are incorporating. This is the training and validation metrics for proposed model. Here we are getting very good very lower training and validation loss, both are we are getting, and we are getting very good values of MAC and ME. Are the accuracy and F1 and training time, and in training time comparison of with the different what are the existing models. So CNN LSTM and the combination of LSTM also. Also we have compared with the new recent model, that is transfer also. But out of that we are getting very good accuracy, that is nearly about 99.1%. And F1 score also we are getting at good range. This is the evaluation study. If you incorporated only LSTM, only CNN, or if only without a data fusion and without error mitigation. So instead of that, we are getting, if you incorporated all these things with CNN, LSTM along with that attention layer. So we are getting very good accuracy. That is 99.1% of accuracy for Mimic 3 data set, and these are the different accuracy for different data set. They we have compared with the three data sets. Conclusion, we are getting very good accuracy in F1 score. So our model is outperform with all other existing models. And in future work, we are working on Raspberry Pi also. So edge model also we are trying to do.